So hello students and good morning everyone. Uh, in this class we will discuss errors and measurement, and we will try to see what type of questions can come in this particular topic. Now we will understand what is significant figures, we'll understand what is rounding off, we'll understand what do you mean by accuracy and precision, and we will do some practice problems. What did we do in the last class? I think in the last class we had discussed what? What did we discuss in the last class?
About 1 year calipers and screw gauge.
Okay, we had discussed 1 year caliper, screw gauge, and all those things, and we had done some questions on this. So that was the discussion in the last class. Let us move ahead. What type of questions come in your JEE? I mean, in this session, the last session that we had one question coming from this errors and measurement chapter in 2022 8, 11, and so on. These are questions from different sections. Therefore, you find so many questions. Remember, at least one question will come either from units and dimension or from these error analysis and 1 year calipers. At least one or maybe two questions can come in your session. So remember that. That is why this question is important. Now let us move on to understand what you mean by significant figures. Any idea what is significant figures? You must have done it in chemistry. What do you mean by significant figures? Have you heard the term significant figures?
Yes.
What do you understand by them? Now, in calculations, whenever we do calculations, we might get an answer, and that answer may have some numbers attached to it. Significant figures is defined as the figure. Significant figures is defined as the figure which tells us what is the trustworthy number, which number you can trust, what is the trustworthy number. For example, if you do a calculation, if you I think we discussed the measurement of something with a scale, and in a scale you can only give the measurement which is only approximately equal to 1 mm. You can say it is 31 mm or 32 mm. If it is between 31 and 32, you will just guess. So that number is not trustworthy. So significant figures, if I talk about significant figures, it basically gives a number which is more, it tells us how precise is your calculation, or up till what precision you have calculated. For example, if I give you that the value of pi is 3.14, and then I tell you that it is 3.1415 something, which is more precise?
Down one, sir.
3.1415 is more accurate, more precise as compared to 3.14, because it is giving you more insight into what is the actual value. In this case, in the first case, the number of significant figures is less. In this case, the number of significant figures is more. So if the number of significant figures is more, greater is the accuracy in the measurement. So significant figures basically tell us how trustworthy your number is, or how trustworthy your measurement is, or up till what precision you have calculated your number. Do we understand this?
Yes.
I'll give you a minute to note this down. Now let us go ahead and try to understand this thing more precisely. For example, this is the value of pi given up till 10 digits. You see this? Just gone away. This is the value of pi which is given very precisely. It is given up till 10 digits. So it gives us more insight or more accuracy in terms of what is the actual value of pi. If I write pi as 3.14 and if I write pi as 3.1415, or if I write pi as 3.141592, as soon as I increase the number here, the value of pi becomes more and more precise. Do we understand this?
Yes, sir.
Everybody is able to understand this, what I am saying here?
Yes.
So this is the value of pi which is given to 10 digits. This is the value of pi which is given to 3 digits. This is the value of pi which is given to 5 digits. This is the value of pi which is given to 7 digits, and so on. The more the number of significant figures we increase, the more precise the value becomes. Everyone understands this?
Yes, sir.
Okay, now what type of questions are going to come from significant figures? Um, you might not get very specific questions. If the question come, it might be from units and dimension, or from vernier caliper, or from error. Significant figure, the questions are very rare in that case, because they will just not give you a number and tell you to find out the number of significant figures in that. They might give you a simple question where the values would be given in decimals and so on, and then they will be asking you to find out the number of the exact value. That question will be a question on significant figures. But to understand how we are going to solve that question, we have to understand how do we calculate significant figures. How do we calculate significant figures? Any idea? So there are some rules that we must understand. Let us move on to understand those rules. The first rule is that a significant figure, if they are non-zero digits, then all the non-zero digits are significant in a given number, are significant without any regard to what is the location. If I take the example of this number 18452, it does not have any zeros. It does not have any zeros. Therefore, the number of significant digits here are 18452. So it becomes 5. Do you understand? The number
Yes.
of significant digits in this number are 5. Similarly, if I could have written this 8184.52 or 18.452 or any combination, this number could have been anything like this. The number of significant digits would have still remained 5. Do we understand this?
Yes, sir.
So all non-zero digits, wherever they have to be taken as significant figures. This is rule number
1.
1. Note this down with an example. Let us move on and see what is the second rule. The second rule, all zeros occurring between, oops, what is happening here? The slide goes away. All zeros occurring between two between significant figures, sorry, all zeros occurring between two non-zero digits are taken as significant, no matter where they are. So if zeros are occurring between non-zero numbers, they are treated as significant. Take the example of this number 106008. Now, what are the number of significant digits in this number? You can count 1, 2, 3, 4, 5, 6. It will have 6 significant digits. If I write it like this, 10.60, if the number would have been like this, or if the number would have been like this, what would be the number of significant digits? Still remains 6. Do we understand this?
Yes.
So if zeros are coming in between two non-zero numbers, no matter where they are, the number of significant digits in those number, you are going to count zeros as well. You understand this?
Yes, sir.
Note it down. Then the problem only comes when you have what? The problem only comes when you have numbers which tend to be less than 1. When the number becomes less than 1, then the problem starts to come. Now, the number is less than 1. In this case, the number is less than 1. Now, the number is less than 1. All these zeros which are occurring from decimal point up till the first non-zero number, that are not taken as significant. Do we understand this?
Yes, sir.
So here these 3 zeros which are coming after the decimal before the number 3, they are not significant. But this 0 which is coming between 3 and 8, rule number 2, this 0 is significant. Do we understand this?
Yes.
So the number of significant figures in this number is how much?
4.
Number of significant digits in this number is how much?
3, sir.
The number of significant digits in this number is 3. Do we understand this?
Yes, sir.
Similarly, if I had this number 0.00507, what is the number of significant digits in this?
3.
The number of significant digits is 3. Do we understand this?
Yes.
Have you noted it down?
Yes.
Then, if you have zeros and they are not followed by a significant non-zero digits, then they would be taken as significant. Do we understand what I'm saying? All zeros to the right of the decimal are significant if they are not followed by a non-zero digits. That means 30.00. How many significant digits it has? It has 4 significant digits because this is telling me the calculation up till 2 decimal points. Do we understand this?
Yes.
Similarly, if I had a number 30.005, how many significant digits this will have?
5.
It will have 5 significant digits. Do we understand this?
Yes.
Everyone understands this?
Yes, sir.
Shall we move ahead? You noted this down?
Yes, sir.
Okay. Rule number 5. All zeros to the right of the non-zero digit. All zeros to the right of the non-zero digit. If it does not have any decimal, are not significant. If I have this number 2030, or if I have this number 20100, or if I have this number 25000, what are the number of significant digits in this?
3, sir.
In this it is 3, and in this
2.
this would be 2. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Next rule, the rule of the exponent. Now, what do you mean by the rule of the exponent? This power, when we have something written in the form of 10 raised to the power of something, this is not taken as significant. The only significant is this number here. Do we understand this? So what are the number of significant digits in this one? What are the number of significant digits in this one?
3, sir.
3. What are the number of significant digits in this one?
4.
4. Everyone understands this?
Yes, sir.
Have you noted this down?
1 minute.
Okay. Let's move ahead and see. These are some of the questions, and you can tell me what are the number of significant digits in this. In the first one, what are the number of significant digits?
3, sir.
3. In this one,
3.
3. In this one,
2.
2. In this one,
1.
1. In this one,
4.
well done. In this one,
5.
in this one,
3, sir.
this one,
4.
this one,
4.
this one,
4.
this one,
3, sir.
this one.
3.
Do we understand how we got this?
Yes.
Shall we move ahead?
Yes.
The next one is rounding off. Now, this rounding off would be required if a specific question comes. In most cases, if the question is going to come in significant figures, it is going to come on this rounding off. They might give you a calculation, and they will give you for certain options, and you will have to round them off and see what is the exact answer. What is the process? What do you mean by rounding off? By rounding off, we mean the process of omitting or removing the non-significant digits. We will remove the non-significant digits up till the desired number of significant digits. That process is known as rounding off. Do we understand this?
Yes.
For example, 3.1415. This is the value of pi till how many significant digits?
5.
5. 5. If someone tells us what is the value of pi rounded off to 3 significant digits, what is the answer? That is what we call the process of rounding off. Do we understand this?
Yes.
This is the value of pi rounded off to how many significant digits?
3.
To 3 significant digits. This process is known as the process of rounding off. Do you understand this?
Yes, sir.
Anyone understands this?
Yes, sir.
Shall we move ahead?
Yes, sir.
Now, again, we have got rules of rounding off. The first rule for rounding off, you must be aware of this rule. Yes or no?
Yes, sir.
What is this rule? If the digit that has to be rounded off or dropped is less than 5, then the preceding digit is left unchanged. If it is less than 5, it is left unchanged. 3.141. This is the value of pi up till how many digits?
4 significant figures.
Now, if someone tells us round it off and make it up till 3 significant digits, so then which number you have to drop? The number that needs to be dropped is this number 1. Yes or no?
Yes.
Now, this number is less than 5. So if I drop this number, the preceding number is 4. This number will remain same. So 3.14 becomes the value of pi rounded off to 3 significant digits. Do you understand this?
Yes.
If now someone tells us round it off to 2 significant digits, then
3.1.
it will become 3.1. Do you understand?
Yes.
Everyone understands this?
Yes.
Shall we move ahead?
Yes, sir.
Have we noted it down?
Yes.
On the other hand, if the digit has to be dropped is more than 5, then the preceding digit is raised by 1. This is a number which is written up till 4 significant digits. You can see this digit. If someone tells us to round it off to 3 significant digits, so the number that has to be dropped is number 7. Do we see this?
Yes.
If the number has to be dropped is 7, which is more than 5, then what do? You raise the previous number, the preceding number by 1, and the value of this number up till 3 significant digits becomes 4.24. Do you understand this?
Yes.
Everyone understands this?
Yes, sir.
We got this? If I had this 5.007, 5.007, this is the value significant up to 4 digits. How do you round off up till 3 digits? It becomes
5.01.
5.01. If the number is more than 5, you raise the preceding number by 1. Do you understand this?
Yes.
You have noted this down?
Yes, sir.
Shall we move on?
Yes.
This is the next one. If the number is to be dropped is 5 followed by digits other than 0, then the preceding digit is raised by 1. Do you understand the meaning of this? For example, I have this 3.1051. This number up till how many significant figures are there?
5.
5. Now if someone tells us to round it off, okay, let me not put this. Okay, let me put it. Someone tells us to round it off to 4 significant digits. What would be the answer? First, let me ask you that. To 4 significant digits, what would be the answer?
3.105.
3.105. Okay, good. If I ask you to round it off to 3 significant digits, then what is the answer?
3.11.
3.11 would be the answer, because the number that we have to drop here is 5, and it is followed by numbers which are not zeros. Then the preceding digit is to be raised by 1. Do we understand this?
Yes.
Everyone understands this?
Yes.
Have you noted this down?
Yes, sir.
Okay. Shall we move ahead?
Yes, sir.
Rule number 4. If the digit that is to be dropped is 5 or 5 followed by zeros, so it may be either 5 or it may be 5 followed by zeros, then the preceding digit is raised by 1 if that number is odd. Uh-oh. Let us try to take it as an example. 3.235. After 5, there is nothing. Or after 5, there are all zeros. Now, this is a number. This is a number which has got 4 significant digits. If I ask you to round it off to 3 significant digits, then what will be your answer? So the number that has to be dropped is 5, and before 5 the number is odd. Yes or no?
Yes.
Then it has to be raised by 1. So the answer would be 3.24. Do we understand this?
Yes.
3.24 would be the answer in this case. If the number preceding 5 is odd, to raise it by 1. You understand this?
Yes.
Everyone understands this?
Yes, sir.
Shall we move ahead?
Yes, sir.
What would happen if the number is even?
Left unchanged.
It is left unchanged. Similar example, but with 3.245. If this is 3.245, which is significant up to 4 digits, I have to drop this number 5. The previous number is even, so it remains 3.24. Do we understand this?
Yes, sir.
Everyone understands this?
Yes. Sir.
Shall we move ahead?
Yes.
Okay, let us now do some problems here. Simple ones. In all these questions, we have to drop one significant figure and give the answer. For example, in this case, you have to change it to two significant numbers. 9.48. What would be the answer?
9.5.
9.5. You have to drop the last significant digits. 7.94.
7.9.
7.9. 6.650.
6.65.
So if you drop 0, it will be 6.65. If you drop 5,
6.6.
it will be 6.6. So it will be 6.65 in the first stage. It will be 6.6 in the second stage. Do you understand this?
Yes.
Okay. 12.78.
12.8.
12.8. 16.351. If you have to make it up till 4 significant digits, then the answer is
16.35.
okay. If you want to make it till 3 significant digits,
16.4.
16.35 will be till 4. 16.3, sorry, 16.4 will be till 4. Do we understand this?
Yes.
Okay, I'm not able to rub this. Okay, now I'm able to do this. Do you understand?
Yes.
This one, I have to make it up till 3 significant digits. What is the answer?
14.2.
14.2. I have to make it till 2 significant digits.
4.4.
I have to make it till 2 significant digits.
8.8.
8.8. Everyone is able to understand this. Yes or no? No, yes.
Yes.
Shall we move ahead?
Yes.
Now, the question that is going to come, they are going to give you some simple question. They might give you displacement of a body. They'll give you the time, and then they will ask you the velocity. Now, in that question, obviously, everyone knows displacement divided by time, total displacement divided by total time will give you the average velocity. But then that question would be of significant digits because they will be giving you velocity in decimals, time in decimals, and then they will be asking you the answer. So you will have to know how to round them off in calculation up till the significant figures. Remember these things and do not forget. In addition or subtraction, if you have addition or subtraction, that is the operation that has to be performed, the final result should only have that many decimal places which is equal to the number of decimal places in the number with the least decimals. Do you understand the meaning of this?
Yes.
So if I am adding certain numbers with decimals and I will get an answer, I'll have to round off the answer to the number of decimal places which are there in the number with the least decimals. For example, if I add 2.2 with 4.08, 3.12 and 6.38, here I know the value. The value that is going to come is 15.78. That is the value that is going to come by addition of all this. But now in significant figures, what is the answer? Because now you have to round it off in addition. So what is the answer in terms of significant figures?
15.8.
15.8 is the answer in terms of significant figures. May I ask you why?
Sir?
Why is the answer 15.8? Why you have rounded off 7? Because the number with the least decimal places was 2.2. So I can only have one decimal place after I can only have one number in the decimal place. The answer that I got had two numbers in the decimal place, so I had to round it off to just one number. Do we understand this?
Yes.
In addition or subtraction, the answer can only have that many decimal places which are there in the number with the least decimal places. Do we understand this?
Yes.
Have you noted this down?
Yes.
Shall I move ahead?
Yes.
Hmm. Rounding off in calculation. In multiplication or division, if we talk about multiplication or division, then the answer must have that many significant figures which are there in the number with the least significant figures. Do we understand this?
Yes.
If I multiply 1.2, 2.54 with 3.26, the answer that I am going to get is something like this. What is the actual answer?
It should have two significant figures.
It should only have, no, to give me the answer.
9.9.
The answer is 9.9 because it can only have two significant figures, which is the least number of significant figures in the numbers that we multiply. Do you understand this?
Yes.
Everyone understands this?
Yes.
Okay. Just give me a moment. Okay. We got this. Shall we move ahead?
Yes.
Okay. Now write down the number of significant figures in the following. It's a simple question. First one, what is the answer?
3, sir.
3. Second one, what is the answer?
3, sir.
Third one, what is the answer?
5.
Fourth one, what is the answer?
1.
Fifth one, what is the answer?
4.
Why it is 4?
Because zeros before or after the non-zeros, or before the non-zero are not significant.
Now remember, this has got a unit. That means this has probably come from some calculation, some measurement it has come. So you have to count all the digits. This is not a number. This is the value of something which has come from certain maybe measurement. So someone has measured this. Do you understand what I'm saying?
Yes.
Someone has measured this. Someone has measured this, then you will have to count all the numbers as significant digits. So in this case, the number of significant digits is not 4, but
6.
1, 2, 3, 4, 5, and 6. Do you get this?
Yes.
Everyone understands this?
Yes.
What about this one? What are the number of significant digits in this one?
5.
This is just a number. So the number of significant digits is 3. But what are the number of significant digits in this one?
5.
This is 5. Do we understand the meaning?
Yes.
When some unit or something is given, then probably that has been determined by a calculation, and therefore you will have to count all the numbers as significant digits. Do we understand this?
Yes.
Everyone understands this.
Yes, sir.
Remember this, because if a question comes on this, you might be having doubts. So it's better that you clear your doubts here only. Do you understand? Shall I move ahead?
Yes, sir.
Rounding off to 4 significant figures in this case. I'll give you a minute to do it. To round it off to 4 significant figures. Yes,
Done.
just give me a minute. Yes, this one,
36.88.
36.88. Correct. This one,
1.008.
1.008. This one,
11.12.
this one,
11.12.
this one.
11.12.
Why 11.12?
Because the before number is even. One.
Just a minute, just a minute. My laptop is going into mode. Just give me a minute. Yes. How many? What is the answer?
11.12.
11.13. Why is the answer 11.13?
Should be raised by 1.
Why? After 5, 5 is not the last digit. 5 is followed by something. If 5 is followed by something, it is more than 50 in that sense. More than 50, it has to be raised. That odd and even rule only implies when 5 is followed by zeros or 5 is not followed by anything. Do we understand this?
Yes.
If 5 has something non-zero afterward, then no matter it is even or odd, you have to raise it by 1. Do we understand this?
Yes.
Everyone understands this?
Yes.
So do not make this mistake. Here also, in this one, you said that how many significant digits were there here?
Which ones?
You don't see. Oh, here. Do you remember this? This is 3. This is 5. Do we remember why it is 5?
Yes.
What about here? The fifth one?
It is 6.
Why it is 6?
Because it is calculated.
It is calculated, but see, try to understand. If I have something written as 0.02, whether it is meter or kg, or simply 0.02, 0.02, if it is written, the number of significant digits is only 1. Yes or no? Now, whether it is in meter or is in kg, the number of significant digits only remain 1 because 0.02 can be written as 2 into 10 raised to the power of minus 2. Do we understand this? So I
Yes.
can raise it to powers. So up till the first non-zero, you can write it in powers. But if it is the calculation part, you only count the number of digits after the non-zero one. Do we understand this? So here the number of significant digits is 4. I think you said 6, right? I just missed my mind. Yes or no?
Yes.
But if it was a number 0.0234
Mm,
then you could have said that it is the number of significant digits are 3. Do we understand this?
Yes.
So try to understand the differences.
So in the seventh case also it is 3.
No, beta, 7 case, it is written as a unit, so it has to be 5. So someone has measured it.
We can write it as 216 and into 10 part 2.
Just you can write it as 269 into 10 to the power 2, but that's a measurement that has been done. So if you follow the rules of significant figures, then it is, since it is measured, that is why it is it has to be taken as 5. Are you getting confused?
No, sir.
You are getting confused with this unit, Newton per meter, right? See, this meter, kg, seconds, they can be measured easily, but Newton per meter, it will come from some calculation. Yes or no? So that is why normally if a question comes, it will not be on this thing, but you will have to understand. Normally, the question that you are going to get would be based on some number, so you should be able to do it. If a unit is mentioned, then you will have to be a bit more careful. Do you understand this?
Yes.
Okay. Shall we move ahead?
Yes.
Then the next thing that you will have to see is accuracy and precision. Now, what do you mean by accuracy and precision? Now, whenever you are measuring, when you are dealing with physical quantities, we are going to measure them. Yes or no? Now, these numerical values that you are going to get, you are going to get it. You are going to get by some measuring instruments. Yes or no?
Yes.
This measuring process is nothing but a process of comparison. You are going to compare it with the standard units. Yes or no?
Yes, sir.
Now, this measured value that you are going to get of, of the quantity may be different from its actual or the true value. Yes or no? It
Yes.
may not be exactly same. The difference between the true value and the measured value is known as error. You don't have to write this, you must understand this. What is error? Error is the difference between true and the measured value. Yes or no?
Yes.
The accuracy of an instrument is the ability of the instrument to measure the value as possible, as close as possible to the true value. Do we understand this?
Yes, sir.
When we talk about precision, and sometimes we get confused with the term precision and accuracy. Precision is if you are measuring something, the more exact the closeness of the observation. Say once you measure you get 9.3, next time you measure you get 9.35. So you are getting the values which are very close. That is known as your precision of your measurement. Accuracy tells us how accurate your measurement is. Precision tells you the closeness of your measurement from one value to the other. If once I'm getting 9.3 and in the next time I'm getting 10.3, that means I was not doing precise calculation. I was not doing precise measurement. Do we understand this?
Yes, sir.
If the actual value of the thing is 10, if I get the answer as 10.1, I will call it accurate. But if I get the answer as 11, I will call it not accurate. Yes or no?
Yes, sir.
If the value of this is 10, in one calculation I get 10.1, in other calculation I get 9.9, I will say my calculations are precise. But if in one calculation I get it as 10, in the other calculation I get it at 11, obviously my calculations are not precise. So that is what we mean by accuracy and precision. Do we understand this?
Yes, sir.
Well, that brings us to an end of this class. What we have done in this class, we have read about significant figures and we have read about accuracy and precision. In the next class we will go ahead and see errors in measurement. Error is the difference between the true and the measured value. Do you understand this?
Yes, sir.
So we'll have a look at errors and I'll see you in the next class. You have understood what we have done in today's class?
Yes, sir.
Okay then. Now a question based on this is very unlikely to come. But yeah, if it comes, you have to keep in mind all those rules. I'll see you tomorrow. Take care.
Thank you, sir.